So in the previous lecture, we discussed about a causal, infinite duration causal sequence Z transform and anti-causal sequence we completed in the last lecture. So let us see the combination of causal and non-causal sequences now, Z transform. So last class we completed these two pairs, right? A power n into u of n. What is it Z transform? 1 by 1 minus a z inverse, where mod z is greater than a. Similarly, minus a power n u of minus n minus 1. What is its Z transform? 1 by 1 minus a z inverse only, but mod z is less than its pole. These two we completed in last class. Now let us see the combination of both positive sided sequences and negative sided sequence. Write the problem. Find out the Z transform of the discrete signal x of n equal to a power n into u of n minus b power n into u of minus n minus 1. Try to solve this problem. So already we have completed the transform for individual signals, right? So linearity property is applicable. Depending on weightage, separately you have to take first signal Z transform, second signal Z transform. Okay. So directly I'm writing here a power n into u of n. What is its Z transform? 1 by 1 minus a z inverse, where mod z is greater than its pole. And we also completed minus a power n into u of minus n minus 1 Z transform. What is its Z transform? 1 by 1 minus a z inverse, mod z is less than its pole. Now the combination, right? Here x of z. What I have to write? X of z, then a power n into u of n Z transform minus Z transform of this signal. Even if you take standard definition also to solve this problem, like how we solved in these two cases. Okay. So 1 by, first Z transform is 1 by 1 minus a z inverse minus b power n plus minus b power n u of minus n. What is it? Z transform 1 by 1 minus b z inverse. But ROC also you have to mention. And mod z is less than b. So this we can write it as z by z minus a plus z by z minus b. So you can also simplify it if you want. You can simplify it, but I am focusing on this is general simplification, taking LCM and together writing all the terms together like that, right? Let us try to focus on ROC now. Try to represent ROC. How many poles we have here? You can clearly see here total. If you take LCM, total 2 poles are there. Where are those poles? At Z equal to A and B. These two are the poles, right? So let us say that A is here and B is here. First ROC, what is ROC? Mod Z greater than A. So with radius as A, first draw a circle with radius as A. First draw a circle with radius as A. Next, mod Z less than B. So first draw a circle with radius, next draw a circle with radius as B. Okay. With radius as B, you draw a circle. Okay. Okay, now represent mod Z greater than A. Greater than A means outside the circle, right? Greater than A, outside of this interior, inner circle. Outside of this circle. Next, what is the next ROC we have? Mod Z less than B. Less than B means inside of this circle. So where is the common ROC now? Is there any common ROC? First of all, observe this angular ring, whatever ring is there inside, in between two circles, this is our common ROC. This region is our common ROC, isn't it? This is our common ROC. So a common ROC is possible only if A is less than B. Observe this. First A is there, next B is there. So A is less than B, then only common ROC is there. And in that region, this is a corresponding Z transform. You can simplify it further. Okay. If A greater than B, there will be no common ROC, hence no Z transform for the given signal. Because external will be there, inside the circle will be there if A is less greater than B means. So common ROC does not exist in this case. Okay. So this is for non-causal sequence. So here what is the conclusion means? For a non-causal sequence, The ROC is angular ring between two circles. Angular ring between two circles with radius as its pole values, with some radius or with radius as pole values. Okay, and causal signal pole must be less than non-causal signal pole. That is the case. If it is greater, means not possible. So for a non-causal sequence, the ROC is angular ring between two circles with radius as pole values. Okay, this is about the third combination. Okay. Next. The heading finite duration causal sequence. Finite duration causal sequence. Okay. So previously, whatever problems we solved, all those are infinite duration sequences. Now we have to take problem of infinite duration. This is one more condition. Write down, but let us see with one example. Find Z transform of x of n equal to 1, 2, minus 1, minus 2, 3. And index value is given here, which represents arrow mark is given means that corresponding to n equal to 0. Causal sequence means positive sided sequence or right sided sequence. Other name is right sided sequence. Okay, that is the other name for this. So solution, this is very simple. 0 means what is the index value? Positive value. N equal to 1, right side. N equal to 2, n equal to 3, n equal to 4. Like that till last one will be n equal to 4. Only one arrow mark will be mentioned in the problem. Let us use the standard Z transform formula, whatever we have. Now out of a minus infinity to infinity, what are the range values? Ranges I have to take signal, whatever discrete signal is given, that is existing only from 0 to 4 only. So let us write here n equal to 0 to 4, x of n into z power minus n. Now expand it, x of 0 into z power 0, x of 1 into z power minus 1, x of 2 into z power minus 2, plus x of 3 into z power minus 3, plus x of 4 into z power minus 2. Now tell me what is x of 0 value? 1. Plus x of 1 value is 2, 2z inverse. X of 2 value is minus z power minus 2. X of 3 value is minus 2. X of 4 value is 3. This is a Z transform for a finite duration causal sequence. So observe here, for a causal sequence, negative powers of Z will be there. Coefficients 1, second 2, minus 1. Directly we can write minus 2, 3, Z power minus 4. So here you can observe ROC is entire Z plane except at Z equal to 0. Because if Z equal to 0 means 2 by 0. 1 by Z square means 0 square. Minus 2 by 0 cube. Something by 0 means infinity. So ROC is entire Z plane except at Z equal to 0. Because this x of Z will be existing for all the values of Z except at Z equal to 0 only, right? So this is a problem for finite duration causal sequence. So next, let us go for next problem. Next, finite duration. Finite duration, anti-causal sequence. Anti-causal sequence. So example, again, find Z transform of x of n equal to, say, let us take the same amplitude values, 1, 2, minus 1, minus 2, 3. But where will be the index now? Here, n equal to 0. So negative sided sequence. Anti-causal means negative sided or left sided sequence. Okay. Now try to solve this easily. We can write directly also. X of Z equal to summation n equal to minus infinity to infinity x of n into Z power minus 1. From 0 to what is this? N equal to minus 1, n equal to minus 2, n equal to minus 3, n equal to minus 4. So here n equal to minus 4 to 0, x of n into z power minus n. So expand it, x of 0 plus x of 1 into z power minus 1, because minus 4 is also there. Sorry. After x of 0, x of minus 1 into z power plus 1, x of minus 2 into z square, x of minus 3 into z cube, plus x of minus 4 into z power 4. X of 0 is 3. X of minus 1 is minus 2 z. X of minus 2 is minus z square. X of minus 3 is 2z cube. X of minus 4 is 1 z power 4. So based on coefficients, we can write 3 minus 2az minus z square plus 2z cube plus z power 4. So here, what is the ROC for this finite duration anti-causal sequence? ROC is entire z plane, except at z equal to infinity. ROC is entire z plane except at z equal to infinity. Okay, this is left-sided sequence, right-sided sequence, like that. Now let us see the combination. Find Z transform for x of n equal to, let us take the same values, 1, 2, minus 1, minus 2, 3, and put arrow mark here, n equal to 0. Here n equal to 0 means this is n equal to 1, n equal to 2, n equal to minus 1, n equal to minus 2. Summation n equal to minus infinity to infinity x of n into z power minus n. But what I have to take the scale? Minus 2 to 2, x of n, z power. Now expand it. X of minus 2 into z square, minus of minus 2. Z power 1. X of 0 into z power 0 is 1. X of 1 into z power plus minus 1. X of 2 into z power minus 2. Easily you can write. X of minus 2 is 1. Minus 1 is 2. X of 0 is minus 1. X of 1 is minus 2 z power minus 1. 3 z power minus 2. So here what is the ROC? Entire z plane except at z equal to 0 and z equal to infinity. Okay. So like this. So till now we have completed infinite duration, causal, anti-causal, non-causal, finite duration, causal, anti-causal, non-causal. Now from this we can write properties of ROC. Okay. Properties of ROC. First one, you all know this property. ROC does not contain any pole, because either it is greater than pole, less than pole in case of Laplace transform, whereas here it is inside the circle with radius as pole or outside the circle. ROC should not include pole, because pole is a value where the function is not existing. Denominator is 0. Next, for finite duration, causal sequence, for finite duration causal sequence, ROC is entire z plane except at z equal to 0. Next, for finite duration anti-causal, finite duration anti-causal means negative sided sequence. ROC is entire z plane except at z equal to infinity. Next, fourth one, for finite duration non-causal, both positive side and negative sided sequence. Non-causal sequence, ROC is entire z plane except at z equal to 0 and z equal to infinity. This is the property, right? Next one, infinite duration we have to write now. For infinite duration, causal sequence. For infinite duration, causal sequence. ROC is exterior of a circle. Exterior of a circle, isn't it? ROC is exterior of a circle with radius, with some radius, right? Mostly the radius is pole. With radius, with some radius R1. That is, how do we represent mod Z is greater than mod R1. Mod R1 means radius cannot be a negative value. So that's why mod we are using. Next, for infinite duration, anti-causal sequence. Anti-causal sequence. The ROC is interior of a circle. Interior of a circle with some radius R2 you take here. That is mod Z less than mod R2. Okay. Suppose if the sequence is a infinite duration, if the sequence is a infinite duration, negative sided sequence, infinite duration, negative sided, sorry, two sided, please. Infinite duration, two sided means both positive side, negative sided, nothing but non-causal. Two-sided sequence, then the ROC is angular ring between two poles or two radius values. Okay, how do we represent it? Mod R1 less than, mod Z less than, mod R2, depending on causal signal pole or anti-causal signal pole, like that. Okay. So for impulse signal, what is ROC? Entire Z plane. Entire Z plane is a ROC for impulse sequence. So for impulse, ROC is entire Z plane. That is the last property. For impulse, unit impulse. That is for delta of n, ROC is entire Z plane. Entire Z plane. Okay, these are the properties of ROC. We completed. Problems also we completed for standard signals. We completed ROC, properties of ROC, and also we completed Z transform finding solution, Z transform problems, right? So now let us move on to the next topic, finding properties of Z transform. Okay, I'm clear in the content. Properties same as Fourier transform, like that. Proofs are not that much required, but still it proves the same procedure like that in case of Laplace and the Fourier transform. But in case of integration is there, here summation will be there. Properties of Z transform. Okay, first one you all know, linearity property, isn't it? So let us see the statement. If x1 of n Z transform is x1 of Z and x2 of n Z transform is x2 of Z, then linearity property states that A into x1 of n plus B into x2 of n. What is its Z transform? A into x1 of Z plus B into x2 of Z. Common ROC we have to take. Suppose here R1 is ROC, here R2 is ROC. Here ROC will be R1 intersection R2. Like that, common ROC we have to take. Proof is also very simple, like in case of all those Laplace and Fourier. Consider LHS. Consider LHS, that is Z transform of the signal A into x1 of n plus B into x2 of n. What is the Z transform formula? We have n equal to minus infinity to infinity, signal multiplied with kernel z power minus n. Multiply z power minus n inside, minus infinity to infinity, a into x1 of n z power minus n plus b into x2 of n z power minus n. Apply the summation. Apply the summation to individual terms. Summation n equal to, separate the summation term. A already I have written, right? A I have written constant outside, x1 of n into z power minus n plus b into summation x2 of n into z power minus n. Now tell me what is this? This is z transform of x1 of n. This is z transform of x2 of n. So here we can write this as a into x1 of z plus b into x2 of z. Hence proved. Okay, next property. Time reversal. Time reversal property. Statement you write. If x of n z transform is x of z, then time reversal property states that x of minus n z transform will be x of z inverse. Proof. So consider LHS here also, again consider left hand side, that is z transform of x of minus n. What we have, n equal to minus infinity to plus infinity, x of minus n into z power minus n. Okay, minus n, let minus n equal to m. That means m equal to minus n. So x of minus n right here as it is. Then what about this m limits? What is n value? Minus infinity is there. M equal to minus of minus infinity will change to plus infinity. N equal to plus infinity, you substitute, this will change to minus infinity. This is x of m and z power m. So this we can write into, we can interchange upper limit, lower limit in case of summation. No problem. X of m into z power minus m whole power minus m. This is how the form x of n into z power minus n. But in place of z, what we have, because instead of m, now I can write it as n also, no problem. N equal to minus infinity to infinity. X of m I am replacing with n, that's it. Z x of n into z power minus n. This is nothing but capital X of z inverse. Okay, capital X of z inverse. Similarly, ROC I didn't mention here. Suppose if R1 is less than mod z is less than R2, if this is a ROC, then here ROC will be 1 by R2 less than mod z less than 1 by R1, because z inverse we will have to write here. If you take limits for z, 1 by R2 less than mod z less than 1 by R1, you will get it. Now, while solving the problem, you will get the idea about ROC. No need to by heart it. Okay. So this is the second property, time reversal. Next, third property, time shifting property. Okay. Third property is time shifting property. Put the heading. Time shifting. Two cases will be there in shifting, right? Left shifting and right shifting. So time shifting property. So first one, only one proof we will see. If x of n z transform is x of z, then time shifting property states that x of n minus k. What is its z transform then? Z power minus k into x of z. Second property, second case, left shift. Z power plus k into x of z. Proof is also very simple. Let us prove the first case. First one we are going to prove now. Consider LHS. What is the LHS on left hand side? Z transform of x of n minus k. In the proof, what we have to take? X signal, x of n minus k is our input now. Input multiplied with kernel form. Okay. So now here obviously let n minus k equal to some other discrete variable p. Then what about limits? P limits. N equal to minus infinity means same. Plus infinity, same limits will be there. Z power minus n minus k. Clear? Z power n minus k I have written. What I have to write here? Z power minus n is there. What about n from this? N equal to p plus k. That we have to write here. P plus k. Okay. Now let us simplify it. P equal to minus infinity to infinity. X of p into z power minus p into z power minus k. K is not at all related to this variable. So let us write it outside. P equal to minus infinity to infinity. X of p into z power minus k. This is of the form x of n into z power minus n. So we can write it as z power minus k into x of z. Hence proved. Isn't it? Hence proved. Similarly, this also. You have to remember these pairs in deriving the for other signal Laplace Z transform. Okay. So I think now you can find this x of n equal to cos omega naught n. Cos omega naught n into u of n Z transform. Because you can write this as e power j omega naught n plus e power minus j omega naught n by 2 into u of n. So u of n you multiply inside. This is of the form a power n into u of n, where a you have to take it as e power j omega naught whole power n. A power m into n, a power mn. A power n into u of n, what is its Z transform? 1 by 1 minus a z inverse. Like that, here also write Z transform for this, then doing the simplification, you will get the Z transform for a cos omega naught n into u of n. Okay. Please try to solve this. You have to get the Z transform of cos omega naught n into u of n as cos omega naught n into u of n. Z transform after simplification 1 minus cos omega naught z inverse 1 minus 2 cos omega naught plus z power minus 2. This is a Z transform what you have to get after doing the simplification. You have to take only this pair a power n into u of n. Okay. After that, e power minus j omega naught whole power n into u of n. So in place of a, we have this e power j omega naught. Here e power j omega naught we have to write. E power j theta is cos theta plus j sin theta. That you have to expand later. After doing the simplification, you will get this. Similarly, you can also do sine also. Okay. For finding sine Z transform also. So let us go for next properties. I think this is the fourth or fifth property. Differentiation in Z domain. Differentiation in Z domain. Okay, statement you write. If x of n Z transform is x of Z, then n into x of n Z transform will be minus z into dx of z by dz. Okay. Proof. So first of all, take x of z expression. What we have, z transform of x of n. What we have is minus infinity to infinity x of n into z power minus n. So apply differentiation on both the sides. On both the sides with respect to z variable. That is dx of z by dz. So here differentiation of this total term means differentiation will be applicable only for this single term. Remaining all the terms are treated as constant. So dz power minus n by dz. Summation n equal to minus infinity to infinity x of n. What is the differentiation of z power minus n? Minus n into z power minus n minus 1. Clear? So minus you can write it outside, and z also n equal to minus infinity to infinity n into x of n z power minus n divided by z. z power minus n minus 1, z power minus of n minus 1, right? Minus n minus 1. Okay. So now z, if you take this side, z into dx of z by dz equal to minus of n equal to minus infinity to infinity n into x of n into z power minus 1. So this is in the form signal multiplied with kernel. So this is nothing but minus z transform of n into x of n. Z transform of n into x of n is n into x of n into z power minus n. So n into x of n, what is its z transform? Minus z into dx of z by dz. Hence proved. Minus both the sides you multiply with minus. That's it. Hence proved. Okay. So many problems also we can solve based on this. Find a z transform of u of minus n using properties. We know that already u of n, what is its z transform? 1 by 1 minus z inverse, where mod z greater than 1. N is replaced with minus 1 means z is replaced with z minus 1 again. So mod z inverse will be greater than 1. So u of minus n will be now 1 by 1 minus z, but mod z less than 1. Because what is the property we have? X of minus n z transform will be x of z inverse. Already inverse there, again whole inverse. Time reversal property is applicable here. 1 by 1 minus z. That's it. Okay. Similarly, differentiation property also we can apply here. For example, a power n into u of n. You can take that problem also here if you want. Next problem, find z transform of x of n equal to n into a power n into u of n. Okay, if this is a problem, a power n solution. We know that this is a standard pair, what we know. 1 by 1 minus a z inverse, where mod z greater than a. Now let us take this as x of n, and this is our x of z. Now n into x of n. What is the z transform we have? Minus z into dx of z by dz. So here n into x of n. X of n is a power n into u of n. So z transform will be minus z into d by dz of, what is the x of z function we have? 1 by 1 minus a z inverse. Nothing but its z transform is minus z into d by dz of z by z minus a. This is u by v rule. We have to do. UV rule we have to do to solve this. Okay. So let us continue this. N into a power n u of n. Z transform is UV rule if you apply, minus z into denominator square z minus a minus z into differentiation of that term is 1. Okay. So like this you can simplify it now. Minus z into z minus a minus z by z minus a whole square. Z will get cancelled. Minus az by z minus a whole square. N into a power n u of n. Z transform. Still, if you want to write in z powers means z, if you take common in both numerator as well as denominator, or if you take z as a common over here, minus az by z, if you take common, 1 minus az inverse whole square. Isn't it? Z, if you take common, 1 minus az inverse, and z square will be outside. Isn't it? Z, if you take common here, 1 minus az inverse whole square, and z square I have written outside. So this is nothing but again, finally, n into a power n into, this is also correct answer. U of n. What is its Z transform? Means minus AZ power minus 1 by AZ power minus 1 by 1 minus AZ inverse whole square. In corresponding ROC, you can observe. This is a causal signal, definitely greater than pole, not Z greater than 1 only. Or pole, whatever pole you will get. Here, what is the pole? Z equal to A only. So, causal sequence. So, mod Z greater than A. That is a pole. So, this is also correct Z transform. This is also correct Z transform. Just Z square I have taken common in the denominator. If you take Z common here, whole square is Z. Z square will come out. 1 minus AZ inverse. Z power minus 2 means Z power minus 2. Like that, we can solve the problems also. Properties applicable. Okay. So, next property. So, just a statement I'll give for next property. That is differentiation we have completed. Whatever properties are required, all those properties only we are discussing with proof. Convolution property. Statement you write, if x1 of n statement Z transform is x1 of Z and x2 of n, Z transform is x2 of Z, then x1 of n convolution x2 of n, Z transform will be x1 of Z into x2 of Z. Okay. Convolution in discrete domain gives multiplication in Z domain. Remember that. Convolution in time domain gives multiplication in frequency Z domain. So proof also very simple. So actually proof let n minus k equal to k, like that we can proceed further. It comes in detail in digital signal processing subject, but let us continue with the proof. You will understand it. Consider left hand side. That is Z transform of x1 of n convolution x2 of n. What is the formula we have? Signal x1 of n convolution x2 of n into Z power minus n. Now substitute the convolution formula over here. Summation n equal to minus infinity to infinity. Convolution formula for discrete domain is k equal to minus infinity to infinity x1 of k into x2 of n minus k into Z power minus n, because x1 of tau into x2 of t minus tau. In place of t, n is there. In place of tau, dummy variable is k. In place of integration, summation is there. That's it. Like that you can compare. Now again arrangement of terms. Summation n equal to minus infinity to infinity x2 of n minus k, you write it outside. K equal to minus infinity to infinity x1 of k into x1 of k into Z power minus k we can write. Okay. Z power minus k. Isn't it? Z power minus k and Z power k, Z power minus n we can write. Just observe here, extra term I am adding Z power minus k into Z power k, Z power minus n. Now tell me what is this? This is of the form x1 of n into x1 of k into Z power minus k is of the form. So we can write it as n equal to minus infinity to infinity x2 of n minus k into, this is x1 of Z into Z power k minus n. Isn't it? Z power k minus n. So now we can write this as n equal to minus infinity to infinity x2 of n minus k into x1 of Z, we can write it outside actually, Z power minus of n minus k. Okay. Almost we have done with the proof. So here what we have left hand side, Z transform of x1 of n convolution, x2 of n, we got it as x1 of z into summation n equal to minus infinity to infinity x2 of n minus k into minus n minus k. So let n minus k equal to some other discrete time variable m. Then x1 of z into summation, m limits will also be from minus infinity to infinity, x2 of m into z power minus m. This is nothing but x2 of z, x1 of z into x2 of z, hence proved. Okay. So like this, this is important, the transform formulas x1 of z into x2 of z. Next, initial value theorem and final value theorem we will discuss in next lecture. So try to solve this problem. X of n equal to a power n into u of minus n minus 2 power n into u of minus n minus 1. Using standard pairs, this take it as a one problem and try to solve this one also. Find the Z transform and ROC for functions, for following functions. Okay. First bit, x of n equal to 3 into 5 by 7 whole power n into u of n plus 2 into minus 1 by 3 whole power n into u of n. Use a standard pairs. In place of constants, we have numbers here. That's it. X of n equal to same problem, whatever I have given that one. Okay. Okay, try to solve these problems. So next, final value theorem and initial value theorem we will discuss in next lecture. Okay.